Hello community! Today we talk about Python classes. And you might say, hey, finally is talking about Python classes. And yes, I know it is great. So, Python version 3.11. What are classes, what they can do? And we focus here exclusively on artificial intelligence for the training, the fine-tuning of LLMs and vision transformer. Everything else I will exclude. I will focus only on this specific use case. Great. So either you read here the Python handbook of classes. Beautiful. Or you just read the first paragraph and try to understand the main wording. Classes provide a means of bundling data and a specific functionality together. Creating a new class creates a new type of an object, allowing new instances of that type to be made. Here I ask myself, what is an object? What is a type? What is an instance? Each class instance can have attribute attached to it for maintaining its state. You know, state, question mark, attribute, question mark. And class instances can also have methods defined by its class for modifying its state. Python classes provide all the standard features of object-oriented programming. And now you get it and you say, oh my goodness, we are in object-oriented programming. And you got it, it's gonna be beautiful. Listen, it's easy. It's a little bit of mumble jumble if you start at the very beginning, but let me show you that it is not that difficult. I give you a task. Please take your pencil and customize the code for training or fine-tuning a transformer model with the Python class. Do the code in the framework PyTorch 2, TensorFlow 2, and a little hint for you, use subclassing, a specific Keras model, override some training methodology, because we want to have here the freedom to compute our own loss function. We want to update the model weights whenever we want it. We have a little bit frozen and a little bit updated. And of course, we want to have the ability to compute the metrics. So start with the task. While you do the task, I have a 12-year-old viewer called Ben down under in Australia who asked me, hey, can you give me from time to time the overview where we are? Ben, this is for you. There are two ways to instantiate an AI model. What is this? In the realm of object-oriented programming, instantiating a model, or to be more precise, instantiating a class means to create an object that is an instance of a particular class. Yes, I know you did not get it, but never mind, I will show you an example in 2 minutes. There are two ways to create here a model. The first one is a functional API that you know. You start from the input, you chain your layer calls for a specific forward pass, you create all your models from the input and the output, and this is it. This is what we do, for example, here in TensorFlow. The second method is much nicer, and this is exactly what I ask you to do. Subclassing the model class. So you see here, we have here the parent class Keras model, and we're subclassing here my model. In that case, you should define your layers in the init method, and you should implement the model's forward pass in the call method. Never mind, I will show you in a second, you will understand it soon. Definition: subclassing is a feature of object-oriented programming that allows you to create a new class that inherits the properties and methods of an existing master class, superclass, base class. This subclass, now subclassing, you see the connex. This subclass now can add new properties and new methods, or it can override some properties and methods of the superclass to provide a different behavior. And this is such a powerful tool when we modify our models. When we say, hey, maybe I want 10 additional layers. Hey, maybe I want to have a different loss function. Subclassing is essential for our work in AI. So this was just for Ben. For all of you who'd now finished with the task, remember the task was customize the code for training a transformer model with class in PyTorch and TensorFlow. You come up with this code and I say, okay, let's have a look at this. So you defined here a new class. And this is defined as a subclass here to our Keras model base class, home class. So it means this class custom train step model inherits from the Keras base model class everything. Then we have our init method. This method is overridden to add some additional attributes. You can see here we have a loss tracker added, a metric added, and a loss function added. Never mind what it is exactly, not that important right now. Then we have the train step method. We override this method too. Called during the training process for each batch of data. Model prediction for the input is computed with self of x, training equal true. The loss between the prediction that is computed and the target in the training phase that is known is computed, this delta, with our loss function. The gradient of the loss with respect to the model's trainable weights are computed and the weights are updated. We have here our torch no grad context to prevent these operations from being tracked here in PyTorch computation graph. Then the loss and the metric are updated with the current batch result. A dictionary is returned that includes the current loss and the mean absolute error. Then we have 3 lines of code. Very bottom, 3 beautiful lines. An instance of the class custom training step model. An instance of this class is created. Second line is this instance is compiled with some Adam optimizer. And third line, the model is trained on a particular data set for a particular number of epochs with some callbacks. Now you might look at this code and say, wait a minute, what you're trying to sell us here? We have here a Keras functionality, but we're operating here in PyTorch. Keras does not exist for PyTorch. And I said, okay, no problem. I also ask you to code this in TensorFlow too. You have here the code PyTorch, and here on the right hand side the code in TensorFlow 2. And have a look how similar this is. This is why I tell you, try to learn as many frameworks as possible. It is not that difficult. And if you make a mistake, you look it up and you find the solution, so no problem. But you see here our init method, our train step method. We compute the loss, compute the gradients, compute the metric and return the values. Then we have here, we instantiate here a class. We compile it and we train the model. It is so similar. And now you say, yeah, this is okay because here in Keras here and TensorFlow gradient tape. So this is TF2. So Keras is for TF2 and you are right. But now comes the nice thing. Starting in autumn this year, 2023, Keras will move over to PyTorch. This neural network API that until now lived over here at TensorFlow in Google will be made available to PyTorch. And you might ask why. And I follow here the guidance by François. And he decided to make Keras multi-backend again. It was at the very beginning, but now with fall 2023, we will do this again. Why? TensorFlow has a market share of 55% to 60%, is the top choice for production ML machine learning. Well, PyTorch has between 40 to 45% market share and is the top choice for research in machine learning. So you see, if you focus Keras only on TensorFlow, you are more or less here limited here. If you think this is here 0, then you have the research, and then you have the production phase. Keras was limited to TensorFlow. And now Google decided, or François decided, I don't know exactly who decided what at what time, to extend Keras here to PyTorch, so in the research domain. And I think this is a great move, because then we have Keras 3, the red one here, spanning everything from the very beginning, from the very first step of research, till you have the final application that runs in Bank of America or any other corporation. So this Keras 3 is not published yet. Currently we are in a beta. It would not recommend that you jump on it right now. Wait 2-3 months, then Keras 3 will be officially released. But we can prepare for this moment. And I thought, hey, maybe I should revisit here in Python 3.11, all the beauty and the functionality that a Python class has to offer, particular for artificial intelligence, particular for fine-tuning our LLM and vision transformer models. So if you want, come along. In Python, a class, and you know this, is a code template to create objects. Let's take the easiest example. I always like to operate with examples. A bank account. Imagine you are just opening a new bank and you say, okay, I want that each of my customers have an own bank account. So what is a bank account? So you define a bank account. You create a blueprint of a bank account. This blueprint is what we call here a class. It defines what a bank account is. It includes the account number, the internal number, the first bank account you provide, a second you open. Then the account holder's name, Mary and Bob and John, and then the balance, 0.000. So those are often referred to as the attributes of the class. But the class can also define what operation, or we call this officially methods, can be performed on a bank account. And one method would be to deposit money, to withdraw money, or to check your balance. So 3 methods you can operate. And the very first beginning I told you a class is something where we have more or less the fusion of data and actions. And now you see here attributes and methods. And this is why the class, a Python class, is so powerful, and why we will encounter it in Keras and in all our AI programming quite a lot of. So I thought I better revisit here what a class can do. An object is created using the constructor of the class. I will show you this in a second. This object will then be called the instance of a class. So we learn an instance of a class, an object are more or less the same thing. Let's have a look at here some Python code, because this is the easiest way to get it. We have here a class bank account. And then we have here our init method. We have here 3 different methods, and that's it. Init, of course, is a special method that is automatically called, per definition, when a new instance of a class is created. If I say, hey, create a bank account for Bob, so then init is called when a new instance of a class, a new object, and this is bank account Bob, is created. Init is often used to initialize the attributes of the class. It's directly under the class statement, initializes. In the case of the bank account, it goes for the account number, 1 for Bob, the account holder name, Bob, and the balance, well, we all start with 0. There you have the special method init that initializes the attribute of our class. Then we have 3 methods. We deposit some money, our balance plus equal the amount we pay. We withdraw some money, balance minus equal amount, and we check for the balance. See, easy. This is all there is to it. So how we do this now? Now that we define the class, we create at the very first instance, we create an instance of the class bank account. How we do this? We say bank account with the number 1 or 2. Now for Alice, Bob had 1, 2, Alice. Bank account. And we have my account. And my account is now the instance of the bank account class for Alice. And if we now apply here the deposit method, so we say here my account that belongs to Alice. Alice deposits now $199. So I have my account deposit $199. My account deposit $199 is calling the deposit method of this instance of this class, which modifies the instance balance attribute. Clear. It goes from 0 to $199. Now there's another option, something beautiful, where we can find a combination of methods. We call this the call method. This call method, as you see here, is just like any other method in the class. It has access to self, which represents the instance of the class, and can therefore call all other methods of the class, so deposit, withdraw, check balance. Can call all other methods via self, and access or manipulate the instance attributes. And normally you would use here this call method to perform a sequence of operation like here. So we see fine, we have access to self, to all the methods. Then we have a transaction type and an amount of money. If the transaction type is deposit, we say here self deposit, here we go, at a certain amount. If it's withdraw plus goes to minus amount. Else, yeah, print the balance. Beautiful. So you will see classes, init, methods, call method. Great. How we do this? Now it's more or less the same. At first we create an instance of this class bank account. Again, 2 for Alice. My account 2 now. And now we apply the call method. And I say now my account, parenthesis, deposit 100. When you do my account deposit 100, you are effectively calling the call method of the my account instance. And the arguments deposit and 100 are passed to the call method. This is different than the other method I showed you before. Remember this here? Where we called the deposit method directly. Now with call, since we have here this multitude of methods, it's passed to the call method. And call knows what to do if a certain transaction type comes in. Beautiful. Remember that the call method is not a standard function. It is a special method that Python calls when you try to use an instant of a class as a function. So the call methods provide a way to abstract a sequence of operation that should be performed when an instance is called. You can include calling other methods, showed you. On the other hand, calling a method directly, the very first example, my account deposit 199, is a more straightforward operation if you know exactly what you want to do and you have only a simple job to do. So you have 2 options, but call we will operate a lot of in our artificial intelligence system. Great. What next? Yeah, this call method can include any code that you like. So for example, if we have a class, we have here the class multiplier and we have here our init, then we do not have to have different other methods. No. It is absolutely okay if you just have a class with the init method and the call method. and all the operations are performed within the call method if this is the efficient way to code it. If you see here, multiplier, we have here init our factor, and then with the call factor times value, and this is exactly what we will call this. We call here multiplier with a factor of 2, and we apply this as double, and double 10 is the result. Double is an instance of the multiplier class that multiplies numbers by 2. And then when you call double 10, it invokes the call method, which multiplies 10 by 2, and you're not going to guess what is the result. So call can also stand alone and do all the calculations itself. Very easy example. 2 people walk into our bank office. The very first customers, it's Alice and Bob. And we are so glad that we have a class available that is a blueprint, because we're going to apply this blueprint to Alice and Bob and identical. The only difference is that Alice gets the number 2 and Bob gets the number 1. That's it. And then maybe they pay a different amount of money into the bank account. That's it. So although Alice account and Bob account are both instances of the same class, are both instances of the bank account, they're distinct objects with their own sets of parameter. The name, the customer number, and their balance. Yes, you know this. State. State is something we will encounter here. What is, in object-oriented programming, the term state? What does it refer to? To the values of the attributes of an object. Let me show you this in our example of a bank account. Alice with number 2. What is the state of my account Alice? The state of my account Alice is account number 2, account holder Alice, the name, and the balance 0. The state are the values of the attributes of the objects. Beautiful. A state can change. When we have methods like withdrawal, or if we pay some money into our bank account, the values of the attributes can change. If we say my account deposit 100, our balance will change from 0 to 100. So we have here now that a specific object has state or maintains state. It is not stateless. This is another wording. But we want stateless. If we do parallel programming of multiple GPU nodes in the cloud, we want to be stateless in our functions, pure functions. This is not the way to do it, because whenever we apply here, for example, a deposit, and we say deposit 100, and then we say deposit 100 again, the values will change from 0 to 100 and from 100 to 200. This is not optimal if you do some parallel programming with multiple GPU nodes. So therefore, we want a stateless methodology. And if you have seen my video on JAX, you know this is the stateless version, JAX. In JAX and other similar libraries, stateless functions are preferred because they're easier to reason about, they're easier to test, and they're more amenable to various kind of optimization. And here we look at parallel processing for our AI task. So for example, Midjourney is running JAX. Beautiful. You remember that I showed you here for the class already this train step where we had here the PyTorch version. On the right hand side we had the TensorFlow 2 version. This is now the third version. This is now the stateless JAX version of exactly the same code. We have a lot of JAX in there, of course, but this is the way how to code it in a stateless version for JAX. Keras 3. Beautiful. And since you watched this video till the very end, there's a bonus for you. we will not only have with Keras 3 that Keras operates on the PyTorch version, that Keras 3 will operate on the TensorFlow version. We have here a stateless version of JAX that will be compatible with this, but we will have a fourth version. We will have a Keras 3 version here for the pure neural network part, where the code will be framework independent. Either we run it on, we have the same, absolutely the same code. Either we run it on a Python, if we run it on PyTorch, on TensorFlow, or on JAX, we have something that is framework agnostic. We will get a fourth way of doing it. So wherever you work, you have your code, and your code works if you put it in a PyTorch environment, if you put your code, your new Keras 3 code, in a TensorFlow environment or in a JAX environment. And I think this fourth version is the real beauty, what's going to come this fall 2023 with Keras 3. This was it for today. I hope you enjoyed a little bit of coding. This was just the very first introduction video to get warmed up. And I think in the next videos, we're going to dive a little bit deeper into our pre-release beta version of Keras. And we will enjoy Keras 3 in its full functionality this autumn. Thank you for watching. Thank you for listening. I hope you learned something. It would be great to see you in my next video.